Hello. Today we are going to start talking about hypothesis testing, which is the last topic we'll be covering in this class. Today we will just be going over the basic principles of hypothesis testing, how it's structured, kind of the basic steps, and then we'll in the next few sections we'll be going over kind of the specifics about actually how to conduct a test. So let's go ahead and get into it. Our objectives for today will be discussing how to define the null and alternate hypotheses, how to state conclusions to hypothesis tests, and then we'll wrap up by talking a little bit about errors and the difference between a type 1 and a type 2 error. Okay, so first off, define the null and alternate hypotheses. So with any hypothesis test, there's always the way the test is structured, there's always two different possibilities that we can state, which we call hypotheses. And let's go ahead and just read over this example to illustrate how this works. A study published in the Journal of the Air and Waste Management Association reported that the mean amount of particulate matter produced by cars and light trucks in an urban setting is 35 milligrams of particulate matter per mile of travel. Suppose that a new engine design is proposed that is intended to reduce the amount of particulate matter in the air. There are two possible outcomes that could happen with the new engine design. Either the new engine design will reduce the level of particulate matter or it will not. Right? These two possibilities are called hypotheses. One of the hypotheses is called the null hypothesis, and the other one is called the alternate hypothesis. The null hypothesis is always the assumption that nothing has changed. In this case, that would be the statement that the engine design will not reduce the level of particulate matter. Right? The alternate hypothesis is the assumption that something did change, which in this case would be the statement that it will reduce the level of particulate matter. So one of the very first critical steps of any hypothesis test is to just establish the two hypotheses, the null hypothesis and the alternate hypothesis. So we'll focus a little bit on that for now and kind of go over practicing how to establish these hypotheses. And then we'll talk a bit about how to proceed with the test after that. So first of all, here's some notation. The null hypothesis is always a statement essentially saying that nothing has changed, right? And it's oftentimes phrased, or it's typically phrased as a statement that a parameter is equal to some specific value. Now, in this section, the parameter that we are going to focus on is the population mean. So if that's the parameter in question, then the null hypothesis would be the statement or the assumption that the population mean, which we use the symbol mu to represent that, is equal to some specific value. And then a symbol that we use to denote the null hypothesis is the capital H with a subscript of 0. So the null hypothesis will be a statement of equality. The alternate hypothesis, on the other hand, is a statement of inequality. It's a statement that the population mean, if that's the parameter in question, is different from some specified value. Okay? There are three possible ways that the alternate hypothesis can be set up. We call these three options either a left-tailed, a right-tailed, or a two-tailed test. A left-tailed states that the parameter is less than the value specified by the null hypothesis. An example would be mu is less than mu0. And then again, the symbol that we use to denote the alternate hypothesis is a capital H with a subscript of 1. A right-tailed test states that the parameter is greater than the value specified by the null hypothesis. For example, mu is greater than some value mu sub 0. And then a two-tailed test states that the parameter is just not equal to the value specified by the null hypothesis. It doesn't denote whether it's greater than or less than, but just not equal to. And the way we state a not equal to relationship is an equal sign with the slash through it. We'd write that as mu is just not equal to the specified value, mu sub 0. Left-tailed and right-tailed hypotheses are called one-tailed hypotheses. The reason why we use this language called tails will become more clear in the next section when we actually go through the step-by-step procedure for conducting a test. But it actually, as we'll see, it has to do with the sampling distribution, and that language of tails has to do with a specific area in either the right or the left or both tails of the normal distribution. So let me back up a little bit here, to this example that we just looked at a minute ago, and we want to establish the hypotheses here. So let me bring up my pen just a second here. Sorry, I like black. So when we establish the hypotheses here, we're going to have a null hypothesis, which we'll use the symbol H0 to represent that, and we'll have an alternate hypothesis. We'll use the symbol H1 to represent that, right? The null hypothesis is a statement of equality, and it's based off of the assumption that nothing has changed, right? So if we read the description here, it says, a study published in the Journal of the Air and Waste Management Association reported that the mean amount of particulate matter produced by cars and light trucks in an urban setting is 35 milligrams of particulate matter per mile of travel, right? Now, the new engine design is proposed that's supposed to reduce that. However, if nothing has changed, that means the mean is still equal to this number, right? So the null hypothesis would be the statement that mu is equal to 35. The alternate hypothesis is the assumption that the new design is working as it's supposed to, which means it will reduce the level of particulate matter, right? The word reduce, that's kind of the key word right here, right? Suggests that the alternate hypothesis will be a left-tail test, right? It will be the assumption that the mean is now less than 35. So when you're setting up these hypotheses, the way you set them up will just require a careful reading of the problem description, right? Null hypothesis is the assumption that nothing changes. If nothing changes, the mean is still equal to 35. The alternate hypothesis means that the mean will now be less than 35. It will be reduced, right? So you want to look for key words like reduce or less than or things like that. Or if the right-tail test, look for words that suggest an increase of some sort. Let's look at a few other examples here. Boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. State the appropriate null and alternate hypotheses. Well, the null hypothesis says that nothing has changed, or there's no difference, so that would be the assumption that the mean is equal to 20. The inspector thinks that the mean weight may be less than 20, so the wording less than suggests that the alternate hypothesis should be a left-tail test, using the statement that the mu is less than 20. Okay. Here's another example. Last year, the mean monthly rent for an apartment in a certain city was $800. A real estate agent believes that the mean rent is higher this year. State the appropriate null and alternate hypotheses, right? The null hypothesis says that there's no change, right? And if there's no change, the mean rent is still equal to $800. The real estate agent believes that the mean rent is higher. The word higher suggests a greater than relationship or a right-tailed test. So the null hypothesis would be the statement that mu is greater than 800. Another example. Scores on a standardized test have a mean of 70. some modifications are made to the test, and an educator believes that the mean may have changed. State the appropriate null and alternate hypotheses. The wording, the null hypothesis, is the assumption that nothing has changed. If nothing has changed, the mean is equal to 70, right? But then it says the educator believes that the mean may have changed. And notice that the word there is just changed. It doesn't say anything about an increase or a decrease, but just a change. So because the type of change is not specified, then we would set this up as a two-tailed test. And the alternate hypothesis would be the statement that mu is just not equal to 70. So that is going to be always the critical first step in doing a hypothesis test, is establishing those two hypotheses. And again, it just requires reading the problem carefully. The null hypothesis is the assumption that nothing has changed. The null hypothesis is always a statement of equality. The alternate hypothesis is a statement that something has changed. And it's going to be a statement of inequality, either indicating an increase or a decrease or just a change. And whether it's a right-tailed or a left-tailed or a two-tailed test will require looking for key words in the problem description. Okay, so the purpose of a hypothesis test is to determine how plausible the null hypothesis is. So really, the big focus is on the null hypothesis and exploring the plausibility of that hypothesis. A good analogy would be to compare a hypothesis test to a criminal trial. At the beginning of a trial, the defendant is assumed to be innocent, and then the evidence is presented. If the evidence strongly indicates that the defendant is guilty, we would abandon the assumption of innocence and conclude that the defendant is guilty. In a hypothesis test, the null hypothesis could be compared to the defendant in a criminal trial. The way this comparison works is that at the very start of a hypothesis test, we assume that the null hypothesis is true. We start by making that assumption. Then we look at the evidence. We gather some evidence. This evidence comes from data that has been collected, and if the data strongly indicates that the null hypothesis is false, then we will abandon our assumption that it is true and believe the alternate hypothesis instead. This is referred to as rejecting the null hypothesis. So at the conclusion of a hypothesis test, we will make a decision to either reject or not reject the null hypothesis, right? So this diagram illustrates the basic structure of any hypothesis test. You would state your hypotheses, and then you would assume the null hypothesis is true, gather some evidence and look at the evidence, and then decide whether to reject the null hypothesis or not. The evidence gathering portion of the test, we will go over that in detail in the next section. Today, we're just going to focus on this overall structure of how a test is conducted. After we gather the evidence and analyze it, we have to make a decision. And that decision will be to either reject the null hypothesis or fail to reject the null hypothesis. So our decision will always be about the null hypothesis. But then after we make that decision, we have to state a final conclusion. The most straightforward will be if the null hypothesis is rejected. If we reject the null hypothesis, the conclusion is straightforward because then we would just conclude that the alternate hypothesis is true. And that's really the purpose of establishing an alternate hypothesis, so that if we end up rejecting the null hypothesis, we'll have something to replace it with. That's the purpose of the alternate hypothesis. If the null hypothesis is not rejected, this is where we have to be careful. If we don't reject the null hypothesis, we are simply saying that there is not enough evidence to conclude that the alternate hypothesis is true. So if we fail to reject the null hypothesis, we are not saying that the null hypothesis is true. What we are saying is that the null hypothesis might be true. However, many times when we fail to reject the null hypothesis, there might actually be some relatively strong evidence against the null hypothesis, but we still don't reject it. And the reason is that, kind of like, if we go back to the criminal trial example, in order to convict a defendant, the evidence pointing towards that conviction has to be pretty overwhelmingly strong, right? What you don't want to do is falsely convict somebody, which does happen sometimes, but it's rare, right? It doesn't happen very often, and that's because when a conviction is made, it means the evidence pointing towards the conviction is almost always very, very strong evidence. Similarly, with a hypothesis test, if we're going to reject the null hypothesis, the evidence against the null hypothesis has to be very strong. It can't just be somewhat strong. It has to be very strong, right? So that's why when we don't reject the null hypothesis, that doesn't necessarily mean there's overwhelming evidence that the null hypothesis is true. It just means there is not enough evidence to justify rejecting it. And we would leave our conclusion as that. A few examples here. Boxes of a certain kind of cereal are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this, so he performs a test. The null hypothesis is the statement that the mean is equal to 20. The alternate hypothesis is the statement that the mean is less than 20. After performing the test, he ends up rejecting the null hypothesis. State an appropriate conclusion. Well, because the null hypothesis is rejected, then it's pretty straightforward. We would just conclude that the alternate hypothesis is true, and then so we would conclude by saying that the mean weight of cereal is less than 20 ounces, or at least that the evidence strongly indicates that it is less than 20 ounces. And that would be an appropriate way to conclude the test. We'll switch things up a bit here. Let's say that, again, boxes of a certain kind of cereal are labeled as containing 20 ounces, but the inspector thinks that the mean weight may be less than this. So he establishes his hypotheses, but now let's suppose that after performing the test, he does not reject the null hypothesis. An appropriate conclusion in this case would be to just state that we do not have sufficient evidence to conclude that the alternate hypothesis is true, or we could say there is not enough evidence to conclude that the mean weight of cereal boxes is less than 20 ounces. And we could just leave it as that, right? We can't make any more definitive statements than that in this case. Now, it's important to recognize that when conducting a hypothesis test, you're never going to prove or disprove any hypothesis. You're always going to simply make a decision based off of the available evidence. And when that happens, there's always the possibility of making an error, right? Because it's not a proof, it's a decision based off of evidence. Errors, with a well-constructed hypothesis test, errors are pretty rare, but there is always still the possibility that they could happen. So let's talk a little bit about errors. And there's actually two types of errors, which we call type 1 error and a type 2 error. And this chart illustrates how this breaks down. But the two ways of making an error. The first way of making an error would be if the null hypothesis is true, but we mistakenly reject it, right? We reject a true hypothesis. This is referred to as a type 1 error. The other way that we could make an error is if the null hypothesis is false, we might mistakenly decide not to reject it, right? If it's false, we should reject it. And if we don't, that's an error. That's referred to as a type 2 error. So this little chart illustrates the two ways of making an error, but there's also two ways of making a correct decision, right? So you're going to make a decision about the null hypothesis, and that decision will be either to reject the null hypothesis or fail to reject the null hypothesis. And then the null hypothesis itself will be either true or false, right? So if the null hypothesis is true, but we reject it, that's an error, right? You don't want to reject a true hypothesis. Specifically, that's a type 1 error. If the null hypothesis is false and we don't reject it, that's also an error, right? You should reject a false hypothesis, and that's referred to as a type 2 error. And then the two ways of making a correct decision will be if the null hypothesis is true and we fail to reject it, right? Failing, if it's true, then we don't want to reject it, right? So failing to reject a true hypothesis is correct. The other way of making a correct decision is rejecting the null hypothesis when the null hypothesis is false, right? If it's false, we should reject it, and that is also a correct decision. So let's just kind of look at a few examples, right? The dean of a business school wants to determine whether the mean starting salary of graduates of her school is greater than $50,000. She will perform a hypothesis test with the following null and alternate hypotheses. It's set up as a right tail test, right, because the wording there is greater. Now suppose that the true mean is $50,000 and the dean rejects the null hypothesis. Is this a type 1 error, a type 2 error, or a correct decision, right? If the true mean is $50,000, that means the null hypothesis is true, right? If the null hypothesis is true, then we don't want to reject it, right? But it says the dean does reject it, so the dean has committed an error. And specifically, this is a type 1 error when a true hypothesis is rejected. Once again, we have the same problem statement, but this time let's suppose that the true mean is $55,000 and the dean rejects the null hypothesis. Okay, if the true mean is $55,000, that means that the null hypothesis is false, right? Because the null hypothesis says that the true mean is $50,000. So the null hypothesis is false, so rejecting it is the right thing to do, because you should reject a false hypothesis. Right? And so this is an example of a correct decision. And one more example, once again, same problem, right? This time, suppose that the true mean is 55,000. If the true mean is 55,000, that means the null hypothesis is false, right? And the dean does not reject the null hypothesis, right? Well, if the null hypothesis is false and you don't reject it, that's also an error, right? If it's false, you should reject it. So this is specifically an example of a type 2 error. Okay, so it's not possible to completely eliminate the possibility of making an error. But what you can do is you can reduce the probability of making an error if you structure the test well. And we'll talk a bit more about this in the next section. But one thing we'll explore is the fact that it can be a little tricky, because if you specifically reduce the probability of committing a type 1 error, that often leads to an increase in the probability of making a type 2 error. So then you have to kind of balance those against each other. Right? So and think about things like what type of error is more serious if it's committed, and those sorts of things. So what this does is it gives us kind of a broad overview of the basic structure of a test. And then in the next few sections, we'll look at the step-by-step specifics of actually how to conduct a test, Hypothesis tests can be conducted for a mean, for a proportion, for pretty much any parameter. If you recall, we looked at how to do a confidence interval for both a mean and a proportion. So now we will explore how to do a hypothesis test for both a mean and a proportion. And then later, at the end of in chapter 11, we'll look at a few specific types of hypothesis tests that are designed for more comparisons of two different populations. So that's what we can look forward to going forward. But just to wrap up this section, we've looked at how to write the null and alternate hypotheses, right, the notation that we use for those, how to determine whether a hypothesis test is left-tailed, right-tailed, or two-tailed, how to state the conclusion to a hypothesis test, right, the right words to use for that, and then how to distinguish between a type 1 and a type 2 errors in correct decisions. So we'll wrap it up here. Oops, sorry. And thank you for watching.